Yeah, thank you very much, Jessica, for the warm welcome and the good introduction. I think I don't have to introduce myself, but yeah, you already mentioned something what I also wanted to mention. But anyways, thank you for joining my talk. And yeah, I'm talking today about running MySQL with confidence. So in the end, or yeah, my talk, the bottom line should be I want to give an advice or an answer to the question if it's a good idea or not to run MySQL on top of Kubernetes. But first up, let me introduce myself to you. It's really nice to meet you all here in person in Berlin. My name is Sebastian Saemann. I'm working at NETWAYS, like Jessica already mentioned. I've been there for over a decade now, so a long time, and I'm the head of managed services there, so that means I'm responsible for all our cloud services, managed Kubernetes, managed databases, managed services. And yeah, but my background is basically from the operation side, and most recently, or the last couple of years, it's not recently, it's the last years, I also did a lot of development, of course. And yeah, at work I love to think forward and bring things forward. And like Jessica already mentioned, she saw my slides. I'm also riding a motorbike, so I love to spin in circles from time to time. So that's me on my motorbike. And if you are interested in this topic, you can chat with me as well. But that's not the story for today. The story for today is, let's imagine we all are in a fictional company, so I don't know, a startup, something like this. And within the startup, we have developed a fantastic brand new web app, so it's perfect, and we are now on the stage to move everything into production. So for now, we just have everything locally on our notebooks, and for now, we need to have, or we have to build the stack, so our CI/CD pipeline, and so on and so forth. And yeah, everything is already running in containers. So we have some microservices around, so most of it is stateless. And it's no matter of choice that we want to use Kubernetes as a platform of choice. Yes, of course, the managed Kubernetes is provided by a hosting provider like NETWAYS, as you can imagine. But the MySQL is set for a database backend. So our application we have is backed by a MySQL database backend. MySQL is, of course, a good choice. It's one of the most famous, popular relational database management systems out there. I think there are competitors, of course, but it's a good choice, so why not? But at this stage, we just not thought about our MySQL database. So we know how to run our stateless workload on top of Kubernetes, but we did not thought about our MySQL. So what shall we do with our MySQL instance? Shall we put it as well on top of Kubernetes? Or shall we run it aside somewhere else? I don't know, more traditionally on bare metal systems, for instance. Or shall we buy in a managed database service? You get the point. But anyway, we have no clue, so that's why we are trying to find a solution on the internet. And on the internet, as you know, you get a lot of opinions. And one of the opinions is something like that. So they're advising don't run stateful workloads on Kubernetes. So not only MySQL, but stateful workloads in the end. But this is just one opinion. You have a lot of opinions, of course. And because our team is very clever and we are smart people, we want to think it through by ourselves. And yeah, let's think it through how we could run MySQL on top of Kubernetes. Option number one would be something like this. So this would be the most straightforward approach. So we have our app. The app is connected directly to a pod. So we are just creating a pod with a MySQL instance within it. But as you might know, this does not work very well because we have ephemeral storage. So Kubernetes is running ephemeral storage there. And as soon as the pod gets rescheduled, it gets rescheduled because of a node failure, a node gets drained, or even if we want to just upgrade our configuration for this deployment or for this pod, the container gets rescheduled and our data will be wiped as soon as the pod gets rescheduled. And then, yeah, it's a no-brainer because MySQL database without data is pretty much useless. Option number 2 would be, why not use MySQL? Pretty much the same as a pod with a PVC attached to it. PVC is the concept of Kubernetes for persistent volume claims, so for having persistent data on top of your, or attached to your pod. This usually adds some latency. So this would work very well because as soon as the pod gets rescheduled somewhere else, like I mentioned, the PVC will follow. So usually this is a, I don't know, block storage or shared storage, and it's attached to the node, and as soon as it gets rescheduled somewhere else, the volume will just follow the pod. So our data is always there, but as I already mentioned, one downside would be it adds some extra latency, and MySQL is usually pretty happy if the data underneath or the I/O underneath is with low latency. And here we have to cycle through the network. That's the point. And also this solution would have some lack of high availability because if you imagine the pod crashes, the Kubernetes controller would take some time. Of course, it's configurable. But it takes some time until it realizes that it is a failed pod, and then it gets rescheduled. And what else is happening then is it can also take some extra time when MySQL needs to recover from the crash. So this also pretty depends on your data size and on your configuration. But in some cases, it can be seconds, it can be minutes, it can be up to hours until MySQL recovers from the crash. Yeah, if we can survive downtimes with our customers, this would be a solution, but not what we are looking for. The next thing would be, why not use MySQL replication? So we could just create a stateful set. So we have pod 0 and pod 1, so in a stateful set of Kubernetes. And we just adding one primary and one replica and set up a replication between those two. Also, problems here are we cannot automatically designate a current primary. So we have to tell the application by ourselves, or we have to do this some kind of manually. Also, we cannot use the Kubernetes service object. So usually your application would connect to a Kubernetes service, and this Kubernetes service would then forward your traffic to all the existing healthy pods. But in this scenario, we would end up in writing something into the replica, which is not very useful. So that's why we have to connect our application directly to the primary, and yeah. In case of a failover, so if the primary fails and the replica steps in, we also have to tell our application somehow that it has to reconnect to the new designated primary. It can be a hook, it can be logic within the application, but we have to think about that we have to do it anyway by our own. Also, restore and initiation of new pods. So in case we want to add some extra replicas or we want to recover a failed replica, it's also necessary that we somehow restore the data, point it to the exact position of the current leading primary in the MySQL replication, and all those steps would be very manually. So all those three options would be an option, but nothing what we are looking for. And so we are doing some more research within our fictional company, and then one of our colleagues stumbles across Vitess. Anybody of you heard Vitess already, or does know what Vitess is? Only one. Doesn't matter, I'm trying my best to explain to you what it is. Vitess is a cloud-native database. It's based on MySQL, so they are using MySQL underneath and adding a layer in between your application and the MySQL instances. You could also say it's a sharding middleware for MySQL. This is what it basically does. It was originally born at YouTube. YouTube had problems with their, you can imagine they had a big or massive scalability issues. And they wrote a software around it to solve those issues there. And that's Vitess in the end. So this is where the project was born. And it's pretty cool because it's now available to the masses and not only for YouTube. And like Jessica also already mentioned, it's a CNCF graduated project. So it's in good company with Kubernetes, Prometheus, and other great software projects there in the CNCF. I think it's graduated already since 2019, so it's there for some time. Also, it's of course highly available. Every component within the architecture is runnable multiple times, or 2 times and more. It really depends on your needs. And like I said, the main reason for Vitess, what I heard was that they tried to solve the scalability issues of MySQL at YouTube, and that's why it's massively scalable. How does this thing work? So this is an overview slide of the architecture of Vitess. So you have on the upper right, you have the application, and the application is connected to the VT gate. The VT gate itself is a stateless proxy, which forwards the queries which it receives to the appropriate tablets. The tablets are underneath. The VT gate itself, it speaks the MySQL protocol, so you can connect just with your MySQL libraries from your application to the VT gate and just talk native MySQL. But you could also use the Vitess protocol. It's based on gRPC. The VT tablet is doing also a lot of stuff, but we can leave it here. That's a control unit or control mechanism for the underneath MySQL. So we have, if this is a pod, we have multiple containers within this pod, and the VT tablet controls and sends the queries in the end to the MySQL server. Yes, what else? We have the VTCTLD. The names are a little bit confusing perhaps, but this is the Vitess control daemon. With the daemon, you are managing the whole cluster, and usually we would connect with the VTCTL client, so with the Vitess client. I will show you this in a demo how this works, but this is in the end the daemon or the API entry point for managing the Vitess cluster. Also, what is very crucial for this thing is the topology service. This topology service is backed by etcd usually. It can also be backed by Zookeeper, or I think there is also an implementation for Consul. And this service or topology service stores the information about key spaces. So this underneath the yellow shard, this could be a key space. About the tablets, so which tablets are in the cluster already. About the shards, how many shards I do have, and stuff like that. So replication graph and more information. So it's very important that this service is working. And also on the left side, the orchestrator. For every key space, there is an orchestrator, and this orchestrator is a MySQL high availability and replication management tool. So this takes care about the replication. So the concept is that within one key space underneath, we have one primary. So we don't have primary replication, so we have only one primary and multiple replicas. And this orchestrator takes care of the state, of the recovery, of the reparenting, and stuff like that. So if we are comparing the 3 options I talked about just in a minute or just a couple of minutes ago, we have some benefits, of course. So because our app is connected to the VT gate, and the VT gate knows which one is the current leading primary and which one are healthy replicas and which not, we have this problem already solved. So this comes with Vitess. Also, thanks to the orchestrator, the automatic reparenting, so if a primary fails, a new replica will be promoted, and all the leftover replicas would then be reconnected and reconfigured to the new elected primary. This is done by the orchestrator. Also, backup and restore. So backup is essential for Vitess. So usually, or in a production environment, you would configure a S3 bucket for putting your backups to. And it takes backups, you can take backups regularly, but when a new pod needs to be initialized, the pod, the initial container, it tries to have a look in the list of the latest backups, and then it takes this backup, restores the backup, and points to the position into the replication so that the pod, the newly created or the failed one, can catch up. So we can lose our data at any time, as long as we have enough replicas, of course. And all relies on the replication. So our data persistency and the high availability is all done through replication. Okay, this sounds pretty good. I think it sounds pretty reasonable, and it's also massively scalable. And now, if we are thinking back in our company, what is about scaling? So what if our application just goes up to the moon and we need to scale out? So how does this work? And how does this work? I want to show you in a demo. I hope that this demo will work, but let's see. I'm using the Vitess operator. The Vitess operator is written by PlanetScale. PlanetScale is also the company behind the Vitess project. And it's pretty cool. The Vitess operator offers some CRD, so custom resource definitions for Kubernetes. And there you have Vitess key space, Vitess cluster, and some resources like this to just create cluster and Vitess resources in a Kubernetes way. Then I'm creating a new Vitess cluster, of course. The Vitess cluster will look something like this. So we have a topology service, we have a VT gate, again, the proxy in the middle, and we have one key space, which is called Rails, because we are adding an application to this whole concept or to this whole construct, and this is a Ruby on Rails application which we are connecting. I just want to show you the connection string, how does this work. It's pretty straightforward, I guess. Then I want to show you how it's done to use or to scale out using more replicas. So this is only for read traffic, to scale out by using or by adding one more VT tablet. And then this is a little bit more complicated, I would say so, but I hope you get the point. If our database is growing and we have one table which is just getting bigger and bigger and bigger. So in this example, it would be our customers table, of course. We have so much customers that we need to think about something. And out of the current database schema, so there are, I don't know, 20, 30 tables, we want to extract this customer table and move it in a live environment without any interruptions to the new key space, which is coming to. And there is a new tandem. So we have a new primary and a new replica there. So we are leaving one non-sharded SQL database, MySQL database, and adding one additionally to it. So yes, that's the demo. Yes. Is this readable for the, yeah, okay. Okay, so let's start. So I'm having right now here a Kubernetes cluster, and the only thing which is running there here, but it's a little bit, no, okay. Here, so that's better. Then you can see it's called Vitess operator. This is the operator which I already started. And what I'm doing now is I'm adding a one Vitess cluster. So this is the custom resource definition, a Vitess cluster, which is going to be created. And if we have a look at the pods now, we can see that it spawns 3 times the etcd service, so our topology service. We will have some backups there. This is just for the initial progress or process. We have the orchestrator, so the vtork is the orchestrator, which then takes care of the replication. We have, like I said, 2 replicas or 2 VT tablets which are starting up. And we have the VTCTLD, the control daemon, and 1 VT gate. So this takes just a couple of time. And then let's see. Yeah, that looks pretty promising. I just have to forward some traffic to our Kubernetes cluster. It's too small, I guess. Okay. Is this better? Yeah, okay. Yeah, so I have now a network connection to my Kubernetes cluster because everything is just within. And what I want to show you now is the VT gate. So this is the VT gate. And you can see here, this was also a mistake to make it bigger. It's a little bit a pain. OK, so we have here the queries per second right now, which the VT gate would receive if we have any connections. And underneath, you can see, you cannot see. It's really horrible. Sorry for that. Underneath you can see we have one key space, it's called Rails, and right now it's in the restoring. So I think, yeah, if I'm reloading, right now you can see we have now one primary and one replication. So our database is now ready to put some data to it. That's what I want to do now. So this is just a demo, just a little bit of data, what I'm importing right now. I hope this is ready in just a few minutes. Yes, there we are. And if we have a look here in the VT-Gate, you can see the received queries, and all are done to the primary, of course, because it all is create table, insert into, and something like that. That's why it goes to the primary. And next would be, I want to show you how the connection string would look like. I hope you can see this. So in my Ruby on Rails, I have a development environment, and I have two entry points. One is called primary, and one is called replica. And in the end, if you have a closer look, you can see the IP address and the port. So this is just a tunnel to my Kubernetes cluster. But those two, the host and the IP, is pretty much the same, as well as the database. The database is called Rails. And here we are using Rails with a suffix. So the suffix is @replica. And as soon as we are connecting to a @replica suffix, VT-Gate knows those queries can be sent to the replicas. And yeah. So that's, okay. I'm sorry, my notebook had to reboot just a couple of minutes before. Okay. That was not planned, but anyways, let me just do this in the background. So I need some services for my running demo, but anyway, so we have data in there. You have seen it, and also I want to show you how to add one more replica. So in the end, it's pretty basic. If you compare those two YAML files, it's just an increase of the replica count, and then what the Vitess operator does is it will spawn one more VT tablet. So this one here, it's just 12 seconds old, and this one will then now restored out of the backup and hooked up to the replication, and until it is healthy, it then will receive and serve traffic for us. And let's see if I can make the demo working. Some Redis. Okay, so there we are. So this is my Ruby on Rails application. It's our customer backend in the end. And what I want to show you here is that I'm now here this is me. I'm a customer right now, and you can see it also here. So this table, those information are stored in the customer table. And what we are going to do now is, I wanted to show you this one. If I'm hitting the reload page, we can see here in the graph that it also adds now the orange line. You can see it perhaps by yourself. And now those read queries, so the inserts and update statements and so on, they are going to send to the primary, and the select statements are going to send and load balance to all the replicas. And of course, I can just increase the replica count to, I don't know, 100, and then I have 100. But this is only useful if you have a lot of read traffic, what you want to solve by scaling out like this. And now what I want to do is this customer table, I want to extract those tables. And therefore, I need to create one new key space. So again, we just added a key space, get pods. You can see it here. So we have a new orchestrator, which takes care of the running replication within the new tandem. So in this new tandem, we have one new tablet. You can see it here. It's 7 seconds old, and the second one. And one of those two would be the new primary and the new replica, but with no data in it. So it's a complete empty key space. And we have still the Rails key space where all my data is. Okay, let's see. I have to wait, sorry for that. We can have a look at the VT-gate. Yeah, so there we are. So you can see we not only have the Rails key space, there is also already the customer key space. And the primary is already healthy. And right now the orchestrator adds the replica to the new customer key space. And I think, yeah, now we are good and have a new database or new MySQL with a new replica running there. And like I said, now we are moving data. Let's see. This is the VTCTL client. And we are adding, or we are creating a workflow. It's a move table workflow, and this workflow now will take the table customers out of the Rails key space and move it to the customer key space. So this just copied now the complete table, moved it to the other database, and added as well a vStream or virtual replication to it. Which means right now, if I'm editing here my user data, all the data is still sent to the original key space, but also replicated to the new one. So all my changes are flowing right now. And if I'm happy with that, I can just switch the traffic. I do it in one step. What I did right now is we talked to the VT-gate, or we said that the VT-gate now should switch all the reads and all the writes. We can do it also in two separate steps. But right now we have some routing rules in the VT-gate where all those queries now are going to be routed to the new key space. So the virtual replication is still flowing, but all the data now are going to be received from the new key space. So this, if I'm reloading right now, those data is coming from the second MySQL instance. I think that's pretty cool, but yeah. And that's it. That's the demo. What I want to show you here, but I forgot. If we have a look at the Rails, so if we are using the Rails schema, okay, it's perfect. We can see we have still the customers table in the Rails schema. And if I'm ready with because right now I just switched the traffic, and now I'm going to complete the whole step. So I'm I'm completing the workflow, and now the table should have, or should be gone. Let's take a look. Use Rails. Yeah, and here you can see the table is dropped, and my application is still working. Or not. You know what I missed? I have the wrong, sorry for that. I just dropped my routing rules. It's VTCTL client complete, and I dropped the table. If I would not do it, I had to add this flag here, keep routing rules, and then my routing rule would still exist, and then my VT-gate would still forward the traffic. So I could add some routing rules by myself, but this would take, I guess, an hour or whatever. So that's not the point. But I think you can you have a you get the point what I wanted to demonstrate. So usually, just imagine it's still working. Yeah. Okay. Yeah, worked quite well. So in the end, so to conclude everything and to give it the answer to the question if it's a good idea or not to run MySQL on top of Kubernetes, yes, depends. I think with Vitess it can be a very good solution. Even the Vitess operator, so this is the Vitess operator, is a perfect match for Kubernetes and the cloud native or the cloud native environment. And yeah, it's quite nice to have such a solution. And for me, it's pretty good because even if we have not this large-scale environment, so we are not YouTube and not one of those hyperscalers, but in the end, all those backup, restoring, replication, all the operational overhead which is done here automatically by Vitess and by the operator, is pretty cool, and you can rely on it. And in the end, you can run your MySQL workload on top of Kubernetes. Yeah, that's pretty much it. That's my talk. If you have any questions, feel free to ask them now. You can visit our website. Also, vitess.io is a good source. This is the documentation in the end. And yes, if you have any questions, please feel free to ask them now, or just grab me at a booth or at an evening event, whatever. So thank you for listening.